Jai Hind. I am Madhup Agrawal, Assistant Professor IT Department, AKGC Ghaziabad. Today's our topic is B tree creation, which is very important topic of data structure. So let's begin. Now first we will see what is B tree. So B tree is a generalization of BST, in that a node can have more than 2 children. Generally in the BST a node have only 2 children, but in this B tree a node can have more than 2 children. How this can achieve, we will see further. And one of the standout feature of the B tree is ability to store significant number of keys within a single node. So this is achieved with the having more values in a single node. Generally, just like in the BST, only one value can hold by the single node, but in the B tree more than one value can be held within a single node, and it significantly reduces the tree height. So what will be the benefit? Reduce the height, hence reducing costly disk operation. So with the help of reducing height, we can search efficiently in the less time. So this is used in the mainly in the disk operation. B tree is used. Now and this B tree, here this B tree, not this is this B tree. This B tree is developed by this Rudolf Bayer in the 1970. This was the two researchers, Rudolf Bayer and Edward, in 1970. And the B tree is a balanced search tree designed to work well on magnetic disk or other direct access secondary storage devices. And B tree is commonly used in databases and file system, which are kept in the secondary storage, as we have discussed. And B tree delivers consistent and significant performance for critical operations such as search, insertion, deletion operations. Effectively, we can create, insert, search and delete in the B tree. So some properties of B tree are there. So one by one we will see. A B tree of order m, here order m. A B tree of order m can be defined as the m-way search tree which satisfy the following properties. Order m, so m-way tree also we can say. All leaf nodes of the B tree are at the same level. All the leaf nodes are the same level, means perfect balanced tree. This is the perfect balanced tree. B tree is perfect balanced tree, means left and right subnodes are at the same level, and each node has at most m children. If the order m, then this order m indicate the maximum number of children nodes. A node can have maximum number of children node, that is m. And in the B tree, all leaf nodes except the root node, all leaf nodes, non-leaf node except the root node should have at least this is the ceiling operation, m by 2 children. M by 2 children means this ceiling operation, this symbol of ceiling, m by 2 children means internal node except the root node have at least the m by 2. If we can say, if the order is m is 5, then internal node except the root node can have at least this number of children nodes. Now the key of the each node of the B tree should be stored in ascending order. All the key must be stored, multiple values can be stored in a single node, so they are stored in the ascending order. Next property, if the root node is a leaf node, maybe case first case only node of the tree, then it will have no children and will have at least one key. And if the root node is non-leaf node, then it will have at least two children and at least one key. So, these are some properties of the B tree. Now, let us begin with the example, just how B tree looks. So, if the order of B tree is 5, then we can say this is a B tree. Here we see multiple key values in a single node, just like here 3 values, here 2 values in a single node, here 4 values in the single node. Okay. So, this is the example of a particular certain B tree. Order 5, what it signifies? Order 5 means maximum 5 children could be there for a particular node. So, if a node having one key value, just in the case of the root node, so how many children? 2 children will be there. If 2 nodes is 2 values are there, so number of child node would be 3, 1 plus, if key value is 2, then number of children node is 2 plus 1, that is 3, means less. This is generalization of BST. So, the value less than this particular key, that is 31, lies in the left subtree, that is 10, 18, 21, and values greater than 31 and less than this particular 44 lies in between this particular child node, that is 32, 36, 40 and 42, and values greater than 44 lies in this particular subtree, that is this one. So, this is generalization of the BST, and here if value larger than the 48, then come to the right side of this particular, that is 56, 64, 85 and something this one. So, this is general we have seen. Now, take the example and create the B tree with the these certain keys values. So, construct a B tree for the following sequence of input for order 5 B tree. So, these are the key. Now, M is 5, order is 5. So, maximum child node may be 5, maximum child node. So, the key value may be how many? 4. The key maximum key value for a particular node, that will M minus 1, that is 5 minus 1. This is 5 minus 1, 4 keys, means a node can have maximum 4 key values. So, by keeping this scenario in the mind, we will start creating the B tree. So, first 3. Now, initially B tree is empty. So, 3 comes. A particular node can hold 4 values, maximum 4 values. So, we can use just like this. Holding capacity of node is 4 maximum. So, first 3 will come in this order. Now, the 14 will come, maybe come here, yes, this can come here, 14 in ascending order, yes, this is in ascending order, 3 then 14, otherwise we will need to arrange. Now, 7 will come here, yes, there is a space. So, but in the ascending order, so first shift this particular 14 and 7 will come here. Now, 7. Now, the key 1, there is a space, so can hold, but in ascending order. So, after inserting the 1, we can write here, after inserting the 1, the key values are 1, 3, 7 and 14. Okay. Now, 8 will come, but there is no space, but if there will be space, there may be. So, the place of 8 should be there in ascending order, 1, 3, 7, 8, 14. Now, we will split. Now, operation splitting. splitting operation will perform in this case. So, the splitting point, what will be the splitting point? Mid of this particular 5 keys, 1, 2, 3, 4, 5. We will consider this also 5 keys. So, splitting point is 5, midpoint of the 5 is 3, third key 1, 2, 3. Split from this point. Now, split from this point and tree go upward, tree grows upward. So, this particular 7 goes upward and split, one split, and the second split is this one. So, 1 and 3 come left side of the 7 and this particular 8 and 14 come right side of the tree. So, our tree become in this manner. Okay. We can visualize this as this is a node. So, holding capacity is 4, we can write this one. Holding capacity is 4, we can also write at this type. Holding capacity is 4, so we can write in this manner. Now insert 5. Now, where to all the nodes, new keys will be inserted in the leaf node. So, keep this in mind. 7. Now, 5 is less than 7. So, come left side, follow the BST property, and here this is a leaf node. So, we can insert here, there is a space, yes, there is a space. So, we can insert 5 in ascending order. So, 5 will come here, 5. Now, 11, insert the 11. Now, 11 is greater than 7. So, come right side. Now, 11, there is a space, yes, there is a space in. So, keep in the ascending order. So, 14 will shifted and 11 will come here, this will be 11. Now, 17 is greater than 7. So, right side. Now, 17 will come here, yes, there is a space. Now, 13, just look, 13 is greater than 7. So, right side, but there is no space to keep the value 13. But if there will be a space, then 30 will come where? In this place, in sorted manner, in this place. 8, 11, 13, 14, 17. Now, splitting operation will take place. So, splitting point among, just right here, splitting point among 8, 11, 13, 14 and 17. 8, 11, 13, 14 and 17, the splitting point to right side, to left side. So, our splitting point will be 13. Now, the splitting point is 13 and this particular 13 will go upside, upward. Now, in the upward node, there is a space, yes, there is a space. So, keep this 13 at here and split this particular node into 2 parts, left and right. So, our tree now, our tree become just like this. This will hold 7, 13. Now, here 1, 3, 5. Now, this is 8 and 11 in between and greater than 13, that is 14 and 17 come here. So, yes, we can manage in this manner. Yes, there is a space for holding 4 keys. So, make it just like this. So, this is 14, sorry, this is 14, 17 and this is 14. Now, next key is 6. Now, insert the 6. 6 is less than 7. So, come here and there is space. So, insert 6. Now, 23. 23 is greater than 7. Now, greater than 13. So, come here, that is 23 in sorted manner. Yes, keep here. Now, 12 greater than 7, less than 13. So, in between node, that is 12. 12 will come here. Yes, in sorted manner. Keep it here. Now, the next is 20. 20 is greater than 7, greater than 13. here there is space, yes there is space, to put the 20 in sorted manner, 14, 17, then 20, 23, 23 will come here. Now this keep the 20 here. Now next, that is 26, 26. So 26 will come here. Just see, just take precaution. We will see there is a space, but don't keep the 20 here, because all new node will be inserted at the leaf. Then split operation, if there is a split operation, then after splitting node can come upwards. So take precaution this one. Now 26 greater than here, 26 will come here, but there is no space. So now split. Splitting point, our splitting point will be midpoint, that is 20. Midpoint of the 5 keys is third key, that is 20. Now 20 will go upside and splitting operation will take place. Now this is, now our new tree, now the new tree is, just we can write here, new tree is 7, 13, just next slide, 7, 13, 20. Okay, we will use a fresh page. 7, 13, 20, then here 1, 3, 5, 6, here 1, 3, 5 and 6. Now here 8, 11, 12, here 8, 11 and 12 in this branch. This is now splitting 14 and 17, 14, 17, and here the key is 23 and 26, 23 and 26. Now split take place. Now we can arrange this as this one. Now 4 keys, all the 4 keys kept here. Here only 3 keys, so there is 1 space left. Here only 2 keys, so 2 spaces are left. We can make here. Now here this is another. Okay. So our tree is going upward side. Now the next key is 4. 4 is less than this one, so come here, but there is no space. But if there will be the space, then 4 will insert here. Now splitting point, midpoint 1, 3, 4, 5, 6, midpoint is 4, 4 will go upside. Okay, there is space, then shift that, no problem. Now after splitting, that is 4, 7, 13, 20. Now split in 2 parts, 1, 3, here 1, 3, now here 5, 6, this 5, 6, and here 8, 11, 12, 8, 11, 12, this is 14, 17, 14, 17, and this is 23, 26. Okay. Now we can make as this one, 4 rooms. 4 rooms means holding capacity of particular node is 4. Now this is 4, this is 4, and holding capacity for this is also 4. Now the new key is 16. Now 16 is greater than 7, this is 4, greater than 7, greater than 13, less than this one 20, so come here 16. Now 16 will come, keep here 16 in ascending order, so 17 will shifted and 16 will come here. Now this is 16 and 18. Now insert 18. 18 is greater than this one, greater than this one, greater than and less than this one. So come here 18 in ascending order. So increasing order, sorted order. So keep here. Now 24, keep the 24. 24 is greater than this one, this one, this one. So come here 24. There is a room. So keep here in sorted order. So this become 24 now. Next is 25. Keep the 25. Where to keep? Just search the room. This is greater than this one. Now this is 25. So 25 will come here in sorted order. Shift this one, and now this become 25. This become 25. Now the next last key is 19. 19. So where to keep 19? Greater than this one, greater than this one, greater than this one, less than this one. So in this branch 19, but there is no room. If there will be the room, so come here 19. So split this particular node. From where to split? The mid is 14, 16, 17, 18 and 19. The mid is 17. So 17 will go upside. 17 will go upside. Where to go? In the sorted order, in between this and this. So 17 will come, try to come here 17 here, but this is also full. So again splitting operation will perform at this particular node. That midpoint 4, 7, 13, 17 and 20, the midpoint is 13. So 13 will go upside and create a new node. Okay. So now in the next page we can see here 13, 4 7s. Now 13 will go upside, then 4 7, this is 4 7, and this is 17 20, this is 17 20 here, and now here 1 3, here 1 3, this is 5 6, this is 5 6, this is 8 11 12, this is 8 11 12. Now here splitting take operation. So in the two parts, this particular, so this is 14 16, this is 14 16, and this is 18 19. Now last is 23 24 5 6, 23 24 25 and 26. So our final B tree for the given keys will be this one. This is the final tree for the given keys. We can also use the capacity in this manner, make in this manner. Yes, there are 4 rooms. There are 4 rooms. Capacity of a particular node is 4. So in this manner we can write 4 key holding capacity. This is 4 keys holding capacity. Keep this 4 key holding capacity. So keep this now 4 key holding capacity. So separate this. This is our final B tree. I think this is clear. We can select another example also. Now this is easy to split. This is easy to split if the order of the tree is B tree is odd, just like 3 in the case. But if the order of tree is even, so from where to split? 4. What means? What is the order signifies? Means maximum number of children, that will be 4 in this case. So the number of keys here 4 minus 1, that will be the 3, and splitting operation take place when a new key is come here, and just like here 4. Now 4 keys is there, 1, 2, 3, 4. Now what will be the splitting point? 1, 2, 3, 4. So splitting point, now the splitting point may be this one or maybe this one, because this is. So if we select the splitting point for our problem solving, this one left in these two, so this is known as left biased splitting. If we choose this one, this is known as right biased splitting. So left biased and right biased splitting, we can choose any one, but generally we will prefer the left biased splitting. So in this case, just see, keep the values, just make it capacity, capacity of a particular node is only 3, keeping 3 nodes. So 3 capacity, now put the 3, now put the 14, yes, this is leaf node, you can use. Now 7, so shift the 14 here and this will 7. Now 1 will come, so the place for 1 is at this point. Now splitting will take place. So we will consider the left biased splitting. So in the key value 1, 3, 7 and 14, if we choose the left biased as scenario, then our splitting point will be this one. So after splitting, 3 will go upside and left node contain only one value, that is 1, and right node will contain 2 values, that is 7 and 14. So our tree will look like something this. Splitting point is 3, so 3 and then 2 parts here 1 and then 7 and 14. Okay. So capacity for holding only 3 values, so make it this one. Now already covered these 4 keys. Now 8 is greater than this one, so come here in sorted order, so 8 will come here. Now 5 is greater than this one, so try to come here, but there is no space. If 5 will come, then this will be space. Now the left biased, in all the problem solving we will use left biased. If we choose right biased, then during our all statements we will use right biased. Otherwise if we mix, then our problem will not solve properly. So left biased, the left biased point, splitting point among 5, 7, 8, 14 is 7 now. So 7 will go upside, keep here 7 and split in 2 parts, that is now 7, 3 and 7 here. Now 3, 7, then here 1 and splitting is 5, 8, 14. Here only 5, now 8 and 14. Yes. This follows the property of BST. So we can also check in this part, this is 14. In this particular node, all values greater than 7 come here, all values greater than 3 and less than 7 will come here, and less than 3 will come here. Now the key is 11, so 11 is greater than 7, so come right here 11, now cut here, this is 11, this is 14, yes. Now the key is 17, now 17 is greater than 7, want to come here, now 17, no space, but try to come here at this particular, so midpoint of the 8, 11, 14 and 17, left bias, that is 11, 11 will go upside. So our tree, now our tree is 3, 7, 11 and this is 1, this is 5 and this is split in two parts. This is 8 and here 14 and 17. Now next key is 13. Now 13 is greater than this one. So keep here 13. So shift all the keys 17, 14 and here keep the 13. Now 6 is greater than 3, less than 7. So come here, right here 6. Now 23 is greater than 11. Now here 23, try to come 23, but there is no space, so splitting point. Now splitting point using left bias approach, that is 14 will come upside, but there is also no space, so 14 will, so 3, 7, 11 and 14. Among these values, the midpoint, left bias midpoint is 7, so a node will created and tree will grows upside. Now 7 and here 3, 11, 14, here 3, 11 and 14. Okay. Now here 1, 5, 6, 1, 5, 6, this is 8, yes. Now here this is 8. Now this is split in two parts, 13, 17 and 23. 13, 17 and 23. Okay. So in this manner trees goes upward. So we can also insert 12, 20, 26 and 4 in the same manner. Just 12 will come greater than this one in between this. So here 12 will come. This is 13. Now next key 20 is greater than this one. So come here 20 in sorted manner. Now 26 greater than again 26 will come here, but splitting point 20 will come here. There is space, so keep our node, two nodes will be there. One is 17 and 23 and 26 will kept here. Okay, this is just like erase this one and attach this is here and this particular here. Erase all this. And next key is 4. So where to place 4? Less than this one, greater than this one. So place here, shift, there is room. So shift in arrange in sorted order 4, 6, 7. So now this is our final B tree of order, even order, that is 4. So means we can see here 1, 2, 3, 4, maximum 4 child node can be there, and maximum key particular node can hold the 3. We can solve many problems on this particular B tree, and this is very useful to keep the record in the hard disk, means in the file system and DBMS. So just see here another example, order 5 ABCD, we can use to keep these values and make the B tree. So we will discuss later. So for now, just here A is less than G. These particular sorting arrange according to their alphanumeric order. Numeric means their ASCII value order. So thank you, thanks a lot, Jai Hind.